Hi everybody, let's go over this naming quiz. Let's look at our first chemical. So we've got this Mg3N2. Thing that we want to do is we want to find where those species are on the periodic table. So magnesium, it's right here. It's right there on that periodic table. And that whole column is our +2 group. And here on this handy dandy periodic table, it's telling us this is our alkali earth metals. We know here everything is +2. Okay. Metal, so we're gonna have to be following some kind of metal naming rule. All right, the other species we've got is this nitrogen. All right, that's right here on the periodic table. And nitrogen, because it's right there, we're going to say that's a -3 charge. Cool. Do we have to worry about what the charge is in the metal here? No, because magnesium is here in this alkali earth metal group. So we don't have to use the Roman numerals. We can go ahead and say magnesium and not have to worry about Roman numerals, and we can get nitride. Why are we putting the IDE ending there? Because we take the root name of that nitrogen there, that nitrogen. Don't know why that shot up like that. Whatever. And we kill the ending and we add IDE. On to the next one. We've got cesium fluoride. Let's find cesium on the periodic table. Pause the video, see if you can find it. Okay, here we go. Cesium, right there. That is that +1 on the periodic table. Okay, is this going to have multiple charges? No. Do we need to worry about transition metal naming rules now? No. So, no Roman numerals necessary. Fluoride, find that on the periodic table. Right over here. That one right there. That's a halogen. That's got a -1 charge. So we have something that's got a +1 charge, that CS +1, and we've got that fluoride with a -1. Okay, that +1, that -1 are going to cancel each other out, and we end up with a CSF, cesium fluoride. Next, tin chloride. Let's find them on the periodic table. Tin, right here. That's right, it's right there. That's part of our metals. It's not quite it is really a transition metal. It doesn't fall nicely in that area that I told you to look at, but it's to the left of that staircase. It's a metal. It's got multiple oxidation states. What are we going to need to use? Our Roman numerals. Okay, do we know what the charge of that tin is? No. What do we know the charge of? Well, if we clear off that fluorine there, we can find chlorine here on the periodic table right there. Okay, that chlorine, that also has that -1 charge. So we're going to have 4 of them as written out in the chemical formula. So we have 4 -1 charges. Rewrite that. Yeah, we're just going to put that negative there. How many positive charges then do we have to have for that tin? Well, we had 4 negative ones. Now we have to have a +4 for the tin. There's only the single tin atom there, because we have no subscripts. So we've got tin. Don't forget your Roman numerals, because it is one of our transition metals. And we have our chloride. Again, same thing. Take off the INE ending, put the IDE because we're naming a metal. Great. Moving on. Lithium permanganate. Find lithium here on your periodic table. Lithium right here on your periodic table. So Li, group 1. Do we need to worry about the Roman numerals? No. Great. +1 charge there. Now you need to know that permanganate. That's one of your polyatomic ions. You probably should know those. And their charges. It is MnO4 minus. Well, we've got a +1 and we've got a negative. Those two will cancel each other out. So we can get ourselves a nice little LiMnO4. On to the next one. Cl2O. Cl here on the right hand side of the periodic table. A nonmetal. We're leading off with a nonmetal. Really good indication that we've got a covalent compound. We've got oxygen right there on the periodic table. 2 nonmetals together. Hey, we definitely have a molecular compound here, covalent compound. So now we have to apply those rules. Well, let's take a look at the first species. That's Cl, and I kind of erased it, but we've got a 2 right there. It's a molecular species. We need to include the prefix di now. And we are, because it's the first atom, we don't change that ending from INE to IDE. We have an oxygen here. We are going to change the ending of it because we're going to treat it like it's an anion. Even though it's really not, we're going to treat it like it is. So we have oxide. All right. Okay, next species. We've got our chromium-3. Chromium-3. Right, yeah, there's chromium. Now, we've got this 3. That's telling us what the charge of the chromium is. It's telling us it's +3. So we're going to write a C, not a whatever that was. Cr, 3+, and 3+. Now we need to know what the next species is. It's that phosphate. That phosphate. What is it? Polyatomic ion. That's what it is. PO4 3-. Hey, 3+, 3-, cancel each other out nicely. So we can go in here and we can write out our CrPO4. We're done, right? No, there's more to the chemical name. Remember that trihydrate right there? Yeah, what's that mean? Well, tri means 3. Hydrate, water. If you ever thirsty, you have to hydrate. Water, 3 waters. So we put a big old dot right there. 3H2O, trihydrate. That's our compound. Okay, let's do the next one. Starts with an H. That's your key sign that this is going to be an acid. So let's go ahead and write out that acid. Now that's C2H3O2. What's that going to be? That's going to be our acetate, right? That's one of our polyatomics. Acetate. If it ends in ATE, you're supposed to immediately think of ick. The ending becomes ick, not whatever that was. Ick. So this is no longer going to be acetate. It's going to be acetic acid. Let's do the silver nitrate. We've got it underlined. Silver nitrate. We have silver here on our periodic table, already circled in red. All right, that tells us we've got a transition metal. We need to be using Roman numerals, right? No, your silver is one of your exceptions. It's only got a +1 charge, so you're never going to write that out. So we've got silver +1. That's a plus. Don't use Roman numerals here. It's your exception. What do we know about nitrite? It is a polyatomic ion. So NO3-. We've got a positive. We've got a negative. These cancel each other out. And we end up with AgNO3. Great. Next one. We have FeOH2. Where's iron? Here's iron. Squarely in our transition metals. Because it's in our transition metals, we know it has multiple different kinds of charges. So we don't know what we're going to need to put in parentheses, but we need to use parentheses. So it comes down to that OH. OH. What polyatomic is that? Hydroxide. Hydroxide has a -1 charge. How many do we have? We have 2. So we have a total of 2 negative charges. How many positive charges can the one iron now have? It's going to have 2 charges. So we're going to have iron 2 hydroxide. Hydroxide. Yeah. Next, disulfur tetrafluoride. We're already seeing the first compound has the prefix di in it. That should be telling us right away we've got a covalent compound. If we go to the periodic table, we see sulfur right here. We see fluoride right here. Yep, both of these are nonmetals. We can now use the prefix to give us the exact count of each atom. Di is for 2, tetra is for 4. Tetris, right? Make all four rows disappear. Tetris, yeah. So, S2, F4. Nice. Next one, HI. Hi. That's an acid. Why? It starts with H. What kind of acid is it? Well, it's only got 2 species. It's got an H and it's got the I. So we're going to say that that is a binary acid. Binary acids are going to have a specific naming structure. We're going to have acid there for sure. And we're also going to have to use the hydro prefix. What are we going to do with that? Iodine, because that's what the I is right here on the periodic table. I. So iodine. We drop drop that INE and we put the ic there. That's how our acid naming rules for binary acids go. So we have hydroiodic acid. Next, sulfurous acid. Okay, let's get some space here to write. That's sulfurous acid. So it ends in OUS. So just like how our acetate, we had 8 going to form ic, OUS is coming from the ending ITE. So we now have sulfite. Now I know you're saying, well, what about that U and that R and the sulfurous? Sorry. But it is coming from sulfite. And that sulfite has the SO3 charge, 2-. You're right. Now we need to make sure, because it's an acid, it starts with an H. The H has a charge of +1, that hydrogen ion +1 charge. So how many do we need? We need a total of 2 of them, because now we'll have a total of 2 positive charges to balance out the 2 negatives. So there you go. There's all your species. Hope that helped out a little bit.